The Bantam planet Pluto is the uttermost object in our planetary group. Many huge numbers of minor frigid planets and space rocks populate this district of room inside the Kuiper belt. Once remembered to be the 10th planet in our planetary group, Pluto was named after Pluto, the Roman lord of the hidden world. Pluto, however, lost that ranking in 2006. As per current logical speculations, the sunlight-based framework contains multitudinous space rocks, a modest number of Bantam planets, and just 8 planets. Our insight into the universe has extended extraordinarily over the recent hundreds of years, and we presently have a smart idea of how planets work, what they're made of, and whether they may house humanity in the far future. Yet maybe there is still an extraordinary deal to find out about the stars in our own system. What secrets has the James Webb Space Telescope finally uncovered about Pluto? Does it harbor life, either known or unknown? And does it have an internal sea? Join us as we explore the unimaginable mystery of what the James Webb Space Telescope found on Pluto that was hidden up and down the 10th planet. Pluto was abundantly respected for a very long time. No one saw that it had the littlest moon in the nearby planet group. The way that its orbit was slanted and oval didn't trouble anybody. Pluto was somewhat of a weirdo, but it was our crackpot child. Many grown-ups could relate to its predicament as an untouchable. The general public felt compelled to defend Pluto, and there was public shock when Pluto was renamed as a minor planet 15 years ago. It is maybe not surprising that the International Astronomical Union reconsidered their meaning of a planet and Pluto was left off the list. According to the changed models, a planet must have 3 qualities. It needs to orbit the Sun, it should be massive enough that its own gravity can shape it into a circle or something close to one, and it must have cleared its orbit of debris. Pluto failed the third and final assessment, so we have a Bantam planet. The term planet has been used in a much broader sense for centuries. During the 1600s, when Galileo pointed his telescope at Jupiter, everybody thought any large orbiting object overhead was a planet. Indeed, even moons counted. When astronomers first found the rocky objects we now refer to as asteroids during the 1800s, they also referred to them as planets. From the beginning, Pluto was viewed as a planet. It was initially found in January 1930 by amateur astronomer Clyde Tombaugh, using photos taken with a telescope. Tombaugh reported his finding promptly to the observatory's head. "I have found your planet X," he bragged. Tombaugh was referring to a speculative 10th planet that would orbit the Sun beyond Neptune. However, things took an odd turn when it was discovered that Pluto was not alone in the universe. In 1992, an object just a tenth as wide was found beyond Pluto's orbit. Since then, nearly 2,000 frozen bodies have been discovered in the Kuiper belt, the coldest region of the planetary group's edges. There could be an extraordinary deal more to come. Questions were raised about the fact that Pluto had so many nearby neighbors. What did these new planets share in common with Earth? Why did they stand out unexpectedly? Cosmologists were confused about what comprised a planet. Professor Mike Brown, a planetary scientist at Caltech in Pasadena, found the first Kuiper belt object at that time that appeared to be larger than Pluto in 2005. In recognition of the TV show Xena, Warrior Princess, its name was changed to Xena. This frozen remnant was formed when the Sun and planets were extremely young. Brown proposed that Xena should be the 10th planet, if Pluto was the 10th. However, if Xena didn't merit the status of a planet, then neither did Pluto. In 2006, conflicts over where to place Pluto and Xena reached a limit. The action culminated at a meeting of the International Astronomical Union in Prague. After broad discussion, an updated definition of a planet was presented for a decision. On the last day of the August meeting, Bantam planet status was granted to Pluto and Xena, given their significance in reshaping our understanding of the nearby planet group. The name is a nod to Brown's work, which contributed to ousting Pluto as a planet. He has since earned the Twitter handle Pluto Killer. Textbooks were replicated and updated right away. However, many planetary scientists have never updated their methodologies, and this is particularly true for those who focus on Pluto. That could be mockery or vindictiveness on their part, but others and I argue in 2 papers that there are also legitimate reasons to dismiss the IAU's definition of a planet. The researchers read various books, articles, and letters to arrange this information. A portion of the papers were extremely old. They represent the various manifestations through which the term planet has been utilized by researchers and the general public, and the reasons were not always clear. Ceres is a model example among Mars and Jupiter. The asteroid belt is where you'll find this. After its discovery in 1801, Ceres was given planet status alongside Pluto. As additional objects were found in the asteroid belt, Ceres was declared to have lost its planet status. Researchers established that Ceres had many neighbors. Toward the end of the 1800s, as per the legend, Ceres lost its planetary status because it was no longer perceptible. This is how Ceres and Pluto were also burdened. The current group now declares that this isn't the genuine story. Even until the 20th century, Ceres and other asteroids were still viewed as planets, though minor planets. A scientific pamphlet reported in 1951 that many planets are known to orbit our Sun, with the proviso that by far most of these planets were small fry, with sizes ranging from that of a city block to that of the state of Pennsylvania. It was only after the 1960s that minor planets became an offensive term. They were seen by spacecraft for the first time by then. Planetary appearances were still present in the largest asteroids, however, most of the smaller ones were strange protrusions. This demonstrated they weren't simply smaller versions of the larger round planets. The way that asteroids frequently fail to clear their orbits is unessential to the decision to rebrand them. What about moons, you inquire? Until the 1920s, they were all referred to as planets or secondary planets by researchers. It's astounding that despite scientific evidence to the contrary, the common practice of referring to moons as planets continues. Non-scientific media, such as astrological almanacs, were largely responsible for the shift. Astrologers in these texts are often derived from planetary arrangements. Astronomers insisted that keeping the number of planets overhead small was easier to see later. However, new data collected through space exploration has reintroduced moons to the planetary family, especially for some gigantic round ones. Distributions beginning during the 1960s, the global galactic associations mean that a planet is, in short, not the main focus. The word has gone through various definitions. In this manner, it may change again. If fundamental, the IAU's definition is frequently shielded on the grounds that it prevents the number of planets from going crazy. What would your life be like if the universe contained hundreds or thousands of planets? How should the average individual perhaps remember them all precisely? What would we put on the lunch packs? In contrast, simple concerns that zeroing in on just 8 arrangements will beat individuals down from looking further into the universe. Maybe, in the end, the meaning of a planet is emotional. In 2015, when NASA's New Horizons spacecraft flew by Pluto, it revealed a planet with much more activity than anyone had anticipated. Nitrogen cliffs, suggestive of Norway's rugged coastline, and methane ice shards were really tall, considered on the dwarf planet. The Earth is scarred by craters deeper than the Grand Canyon, and frozen volcanoes' peaks are higher than the Himalayas. The cameras on board the spacecraft captured a massive heart-shaped feature on the distant globe, which excited millions of fans on Earth. 8 years have passed since researchers got that first breathtaking sight, but they are still examining the world through open-minded perspectives. Since New Horizons was going at 32,300 miles per hour when it made its closest approach to the dwarf planet, it was only able to take detailed photos of the side of Pluto that was pointing toward the Sun. One of them was quickly obscured by darkness. As researchers have analyzed the nearby views of the close side taken by the spacecraft days before it zipped past, they are beginning to look at pictures of the other half. Researchers refer to this region as the far side, or the dark side. Despite the low resolution, the photos clearly depict the landscape with detail down to around 1 mile, that is, all things considered, multiple times more detailed than pictures captured by the Hubble Space Telescope, which orbits the Earth. Researchers now have a new perspective on this unique world due to the examination of many pictures revealing insights into questions such as whether a sea lies underneath the icy surface and how substances freeze out of the atmosphere to shape the planet's surface. The measurements even lend belief to the possibility that the cold world could support life. However, there are secrets presented by the photos. For example, the ice parts that look like skyscrapers were recently found on Pluto's far side, but they now seem to orbit the planet. Because of this, their origins are among the dwarf planet's greatest mysteries. Richard Binzel, a planetary scientist at the Massachusetts Institute of Technology in Cambridge and a New Horizons co-investigator, says Pluto is the gift that continues to give. Then, in 1996, researchers were able to see surface details at a resolution of 310 miles, thanks to the Hubble Space Telescope. The photos were hazy, but they showed a planet-like globe with higher global contrast than any other planet in the solar system, including Earth. In July 2015, New Horizons famously noticed a heart-shaped feature just north of the near-side's equator, confirming that Pluto is indeed a unique world. Sputnik Planum, a frozen basin teeming with enormous glaciers, is located within Pluto's left ventricle and is now known to significantly influence the planet's dynamic. Beats of sublimating ice rise out of sight as the sun warms the frozen plain, only to fall again. The beating creates dusks of the heart-shaped Pluto. Francis Nemo, a planetary scientist at the University of California, Santa Cruz, and his associates noticed something odd about Sputnik Planum not long after the first photos of Pluto's near side were sent to Earth. It is located nearly entirely opposite Pluto's largest moon, Charon. The chance of a collision occurring is 5% at most. In any case, simulations show that an underground ocean began to rise into the crack just as the basin was forming. Nitrogen gas from Pluto's atmosphere combined and froze in the icy cavity. Pluto's current arrangement is the result of tremendous pressure caused by the accumulation of extra water and ice. The idea of a sea beneath the surface isn't new, but the far side photographs have provided significant support for this hypothesis. Some of the most convincing evidence comes from the turbulent terrain, a confusing interwoven of slopes, crevices, and fields situated on Pluto's opposite side from Sputnik Planum. Researchers believe that an asteroid or comet impact caused seismic waves to tear through and around Mars, Mercury, and Europa, one of Jupiter's moons. When these tremors finally crashed on the opposite horizon, they tore the surface in a manner similar to what we see on Pluto's icy moon, Charon. Planetary researcher Oliver White from the SETI Institute in Mountain View, California, who didn't take part in the concentrate yet made a geologic guide of the far side, fights that the features appear to impersonate ones noticed somewhere else in the planetary group. Yet the goal in the picture is low. A larger part of different researchers share this assessment. Maybe we won't know except if we make a return trip. The disclosure of various breaks on Pluto's far side, among other land eccentricities, lends belief to the possibility of a subsurface sea and may even provide insight into the planet's arrangement. For quite a while, researchers have speculated that Pluto's sea had a frozen start, implying that it was frozen at the time the dwarf planet was formed. Eventually, the radioactive rot in its rough center would have produced sufficient heat to melt it. The ice would have contracted as it softened, causing breaking on the surface. This development of the ice as it froze would have led to surface cracking. If this is the case, then Pluto's surface ought to seem badly creased and cracked in photos taken recently. However, New Horizons only captured pictures of gaps, showing that the dwarf planet's sea was once fluid but has now frozen somewhat. For example, photographs of Pluto's far side show a gigantic crack that runs the length of the planet's near side. It has advanced directly, folding over the whole dwarf planet from the North Pole toward the South Pole. On the contrary side, like the East African Rift System, which isolates that continent in two, this one also separates bodies of land. Pluto's fracture, rather than Earth's, is probably a scar from the freezing and consistently extending sea, rather than proof of moving continents. The age of the fissure demonstrates that the fluid sea quickly began to cool after it was exposed to the air. If this is the case, marine life could thrive there. The dark red shade of the water suggests that it is stained with organic particles, which were seen in tests that likely spilled out of the sea on the near side. The complex organic matter, with a rosy brown variety, has been made in the lab by radiation similar to solar wind or cosmic rays. Consequently, it is plausible that this could occur on a world like Pluto. In addition, ammonia permits the development of atoms fundamental for life, such as the bases found in RNA and DNA. Red ammonium ice on Pluto's near side is a significant marker that the dwarf planet might be rich in organic compounds. The idea, which has gained a lot of support among planetary researchers, doesn't suggest that life started on Pluto but rather that it could survive if given the right conditions. The far side measurements have accomplished more than merely help in the quest for life on Pluto, they have also generated various mysteries. Researchers were surprised to see ice pieces the size of skyscrapers in the easternmost part of the near side in the initial photos sent back from the James Webb Telescope, incidentally reaching heights of 1 mile, multiple times the height of the Empire State Building in New York City. These edges are similarly distributed and rise sharp and knife-like high up. They might reach a length of 19 miles. It would be a nightmare to try to navigate around here. However, until scientists found what lay on the opposite side of the planet, they remained a simple blip. The ongoing map is foggy, but it's not difficult to make out that the bladed geography continues around the whole fringe, returning on the western edge of the near side. They are one of Pluto's major secrets since they span a region on the far side that is multiple times as immense as their extent on the near side. On good heights and levels, spectral measurements show that the sharp edges are made of methane ice, forming a belt around the equator. Anyway, no one knows for sure how they originated. Possibly like ice on Earth, methane in the atmosphere set and tumbled to the surface. Perhaps they are the remnants of a covering of methane ice that the intense sunlight has eroded. The sharp edges have inspired some specialists to consider the second chance, as they are similar to structures that arise in the Andes, but on a much more limited scale. The penitents of South America are only a few meters in height and form in rugged regions. Light is thought to play a part in the development of penitents since they point toward the sun and develop close to the equator, where solar radiation is most intense. Sublimation, the process that evidently cuts down box between edges, is supposedly driven by sunlight. One thing is certain, figuring out the frigid pieces in Pluto's territory more generally requires a deep dive into the dwarf planet's environment. The history of Pluto is significant of mankind's endless quest for knowledge and the dynamic nature of how we understand the universe. In the meantime, scientists will further develop existing climate models to better reflect observed peculiarities. They need to endeavor to reproduce the conditions of Pluto's climate and possible sea in a laboratory. The James Webb Space Telescope will be pointed more directly at the minor planet. While it can't take high-resolution pictures of Pluto, it can use longer wavelengths and is thus likely to find something surprising. Now we're left contemplating whether Pluto will ever answer our age-old questions.